Hey everyone, I'm Ecem. I'm one of the organizers of NODE21 Challenge. In this short video today, I would like to talk about how you could set up your Docker container in order to submit your solution for the generation track of NODE21 Challenge. First of all, let me start with prerequisites. First of all, we are using Grand Challenge platform in order to automate all the evaluation process. Therefore, you need to have an account in Grand Challenge and you need to be a verified user. In order to be a verified user, you need to basically enter all the information correctly, your name, your surname, your affiliation, and then you need to request to be a verified user. And after that, Grand Challenge team will take a look at your request and they will evaluate whether all the information is entered correctly, and then they will approve your request. So basically, if you have any kind of problem with that process, please let us know and we will take a look at it. Secondly, you need to install evaluators package. This is a Python package developed by a Grand Challenge team, and our template repositories are based on that. You could easily install this package by using pip install evaluators command. You need to install Git large file system in order to push and pull model weights. Of course, you need to install Docker because you are going to wrap your algorithm into a Docker container in order to submit your solution to NODE21. And if you're using Windows, we highly recommend that you install Windows Subsystem for Linux because this works best as a development environment, or you could directly install Linux that already works very well. All right, so I would like to mention a few links that could be actually useful. First of all, there is a general tutorial on how to create a Grand Challenge algorithm. This is in the link here. Basically, they showcase a simple algorithm and they show how you could actually wrap that into a Docker container, which is compatible with the requirements of Grand Challenge. So that could be useful to take a look at it. Secondly, you need, as I mentioned before, you need to be a verified user in order to submit your solution to NODE21. So for that, please take a look at this link that explains how you could request to be a verified user. And then we are providing 2 template repositories, one for each track, for detection and generation track. So we highly recommend you look at these template repositories and try to model your own algorithm based on these template repositories. And now I'm going to explain how this template repositories for the generation track was structured so that it could be useful when you're creating your own algorithm. So as you know, we already published these 2 baseline repositories in GitHub. And now let me explain how the generation algorithm that are submitted to NODE21 should work. So nodule generation algorithms, or the nodule generation track, aims at development of algorithms that can generate nodules at the requested location in chest radiographs. So for that, the algorithms are expected to receive an input as a chest X-ray image, which will be read from /input/ the name of the file .mha, and they should also receive a nodules.json file from a location /input/nodules.json. Nodules.json file is a particular format that is compatible with the Grand Challenge requirements. It's a dictionary and it will denote the location of the bounding boxes that needs to be generated. So this is an example of nodules.json file on the right side that you see. As you say, it's a dictionary, and each corner's item will contain 1 bounding box, and they will have an associated likelihood that is denoted with that. So here, for example, there is 4 points of these bounding boxes, and then there's an associated probability, associated likelihood is 0.6. Okay, so once the algorithm reads a chest X-ray image and nodules.json file, it should produce an image after placing the nodules at the requested location. And these images should be written to /output/ the name of the image.mha file. All right. One very important thing is that in the test phase, when you submit your algorithm to Grand Challenge, we are going to provide 3D volume as a full chest X-ray. So that means that all images that are going, so basically the images that we are going to provide will be stacked together, and at the end we will provide a 3D volume. So it means if we are going to, for example, provide you 5 images, we are going to stack them together, and the images that your algorithm will receive will be 5 by 1024 by 1024. The reason why we do that is because if we only provide a single image to you, and if it is, for example, 200 cases, it means that your Docker container needs to run 200 times, and it means that your model weights needs to be loaded 200 times. It's a very time-consuming process. So that's why we came up with that solution. So because you are going to get this 3D volume, now you could just read the image slice by slice, and then you could basically place the nodules in chest radiographs, and then you could return this 3D volume as the final output of your algorithm. How are you going to understand which image, which bounding box belongs to which image slice? And for that, you are going to use the Z coordinate of the bounding boxes. So here in this example, for example, we have these bounding box coordinates, X, Y, and Z, and the Z coordinate will be used as the identifier of the slice. So if this is 0, it will mean that this bounding box belongs to the slice 0. And for example, if this was 6, it will mean that this bounding box belongs to the slice 6. So this is also how we are going to use how we are going to basically calculate the performance of your algorithm in the evaluation process. All right, now let's take a look at the code together. So here I cloned the template repository already, and I will try to explain a little bit how the code was structured. So on the left side, you see all the files, and there are a couple of script files here. For example, test.sh and test.bat, export.sh, export.bat, build.sh, and build.bat. These are basically like some script files that let you to build your container, test your container, and then export your container. So you could look at the command lines and you could try to understand what they're actually doing. And then I will try to showcase how actually they work later in this video. But basically, if you are using Linux, you could use the shell script files, or if you have a Windows subsystem for Linux, you could run these shell script files, or if you're using Windows, you could use directly the bat files. All right, so the main file that is going to be run by your Docker container is process.py. In process.py file, we do almost everything, basically. So when you run this file, it's going to create first an instance of this nodule generation class, and then it is going to call the process function. So process function is a function from evolutils, and when process function is called, it is going to call the predict function, as you see here. So let's go through, for example, step by step. First of all, what happens when I create an instance of this class? So here, as you see, when the instance of the class is created, we read the nodules.json file that will tell us the location of the bounding boxes that needs to be generated in the image. And here we load and we save them as a self data. And then we mention that where are we going to read the input and where are we going to output file, and etc. All right, once we already make this ready, we could already look at what the predict function is doing. But just to bear in mind that we are not using here any kind of deep learning model. So this is like an image processing technique that our baseline repositories are based on. But if you are using a deep learning model, what you would want to do is that you would want to load your model weights in the init function so that you could directly use this model to perform an inference in your predict. So here we did not do that because we do not really have any kind of model. But if we have a model, we would suggest that you load your model, you prepare your model in this init function. All right, so what happens in the predict function is that predict function receives a simple ITK image, and then it will process this image. It will place the nodules by looking at the nodules.json file from our self data, and then it will return the final output as the image after placing the nodules on them. So let's go step by step to a little bit understand what we are doing here. So it basically converts the image to array, and after that it iterates over the image of the 3D volume. So as I mentioned before, since we are providing this 3D volume, it should read a single chest X-ray slice by slice, and that's what we are doing here. We iterate over this 3D volume, and then we read a single chest X-ray here. And then we apply some kind of scaling, and then we have our nodule data. We look at which which kind of which bounding box predictions, which bounding boxes that were denoted in nodules JSON file belongs to this chest X-ray image, and then we take it as a nodule data, and then we iterate this over this nodule data. So it could be that maybe we want to generate three nodules, three bounding boxes on a single chest X-ray. So we iterate on this. And then we apply some kind of processings. We first rescale a chest X-ray image, where we get our bounding boxes coordinates from this nodule data. And then we basically paste this CT patches, CT nodule patches to chest X-ray. And then we again applied some kind of scaling techniques. And then we apply Poisson blending as a post-processing, so that the local discrepancies after we paste this nodule on the chest X-ray could be reduced. Okay, and then we basically copied these results to our nodule images, volume. So it means that this all the images that are generated will be contained in this nodule images NumPy array, basically. All right, so this is how the process function works. So I think it is pretty straightforward. You just prepare your model when you create an instance of your class, and then in the process function, you run the prediction. That means that you are receiving chest X-ray, you have your nodules JSON file, and at the end, you should return the chest X-ray after placing the nodules on them at the requested location. And once you return that, evaluators will take care of it. It will already save this final chest X-ray as the output. All right, so what you need to do in your Docker file, first of all, you need to get your base image, and then you need to copy all of your files inside your Docker container. And then it is basically just running the process function for you. That will be the main file that will be running from your Docker container. So we also have some utility functions that are, I think, very self-explanatory, and that's what we have used when we called our predict function. And these are basically just to apply post-processing as Poisson blending, resample the CT patches, rescale them, and etc. And you could take a look at them, but they are basically just a simple image processing techniques. All right, so now let's run a Docker build, test, and export command, and let's see what happens. So I have basically cloned this NODE21 generation baseline repositories here. So let's go to our folder. As you see, all the files that are here, and now I could build my Docker container and see whether it works as expected. Perfect. So this process could take longer normally, because I have already built it before. It was very fast for me. So this container basically is built and tagged as nodule generator latest. Now I can basically run the test sh that will also build the container, and it will test whether the container works as expected. So first of all, let's take a look at what test sh does. So it will basically run the container, and then it will check whether the output results JSONs are exactly the same with input expected output JSON. So these are our test images. The algorithm, the Docker container, will run on this MHA file, and it will look at the expected output JSON, which denotes what are the file names that were being run and produced by the container. And if basically this expected output and the output result JSONs are the same, it will return that test successfully passed. Otherwise, it will return that expected output was not found. All right, so now let's run this script. Perfect. All right, so basically what we could do now, we could basically run the Docker run command that I have already run similar commands before. So it's like docker roman. I'm choosing the GPU, and then I need to map the input directory. So I'm going to map it as Timo NODE21 generation and then test folder. And then the output directory, I could just keep it like this. And this was, I think, the nodule generation latest. So when we build the container. So let's see what happens when we directly run this command. All right, so it's basically going to read the test array and nodules JSON from the test directory, and then it will write the output to the output directory that we have denoted. So it says that the totally it took around 6 seconds. Okay, so the reason why I run directly this docker run command is because I want to see the output, whether the output is produced correctly. Because when we run the test sh command, it just checks, it runs it, and then it checks whether the expected output and the results JSONs are the same. But you might also want to run this yourself and look at the output. So for example, we could look at the output here. We could go here and then look what kind of files are there. Okay, so here I have already used this as an output folder for the previous run, but as you could see, there is a results JSON that was produced, and then 77.mha file that is produced by this generation container. So we know that it basically works and it produces the output that we expected. Okay. All right, so now we could basically run the export command. In order to save the container. So this basically, this script file is going to save the Docker container with an extension of tar.gz, so it's tar.gz format. Once you see that this Docker container is saved, it means that you are ready to submit your algorithm to Grand Challenge. And in another video, we are going to explain how we could basically upload this model to Grand Challenge and submit it to NODE21.